Hello there, thanks for coming onto this video. This is the fifth in a series of videos that I'm doing to outline and summarize a book that I've created around solution architecture and a framework I've created for solution architecture called the SPIDERCIA framework. So in previous videos, I've covered the framework, my view on solution architecture, the context of solution architecture within the enterprise, the role and skills of the solution architect, and the how to do solution architecture in the context of Agile delivery. What I'm going to do now is this is the topic around information system design, and also in this video we'll cover deployment and infrastructure. So these are the third and fourth topics in the SPIDERCIA framework. So before I move on, so a bit about the book. So this is a book I wrote to provide guidance and my view of some best practice around the practice of solution architecture, and a framework that I've written to help with the practice of solution architecture called SPIDERCIA. So the book covers obviously solution architecture itself, requirements into solution architecture, the people as in the stakeholders, the process, the business process, and the requirements, exceptions, criteria which drive solutions. The information system design, so these are the applications and data, which we're going to cover in this video, and the deployment of those applications and data, again, we're going to cover that here. The testing of the solutions, the governance in terms of is it fit for purpose, is it there are all the risks managed effectively, the automation of the solutions using established processes like CI/CD and DevOps, and ensuring effective operation of the solution in life, all delivered using Agile methodologies. A little bit about me. So I'm an experienced IT professional with many years experience in the industry, covering many different business domains and the entirety of the IT lifecycle. But I've always felt most at home, and probably think that's probably what I'm best at is solution architecture, and it's the area I've got great passion about, to the extent that I wrote a book about it, showing my my views on best practice and how to carry out a solution architect's role most effectively. So a bit of recap on SPIDERCIA framework. So as I outlined in previous videos, I think the first video covered this in more detail. SPIDERCIA contains a number of topics which break down the practice of solution architecture and the delivery of solution architecture. And we've covered these two topics in the last two videos. But the topic is really a means of bringing together the key elements of parts of a solution, and the threads are encouraging collaboration of the different elements of a solution, because you often have different specialists that may be working in applications or infrastructure or testing, but they need to collaborate, they need to work together to have an effective and an optimal solution. So that's what the threads are about. Again, I cover that more in the first video and much more detail in the book. But these are the two topics we're going to cover in this video. So a bit about information system design. This is really all about the applications and the data that the applications process. So any information system solution is going to have applications and it's going to have data. You're not going to have a useful solution without data. So what I cover in this topic is some of the key decisions you have to contend with when designing your applications and designing the data that the applications will process. So we see this format quite a lot in these slides and in the book. These are what I call decision schemas, and they're effectively checklists to help guide and ensure that you consider and address the key elements of design. In terms of the applications, you're going to have decisions to make around what software do you use and where you deploy that software, in terms of, well, for example, common uses, do you deploy it yourself? COTS is custom off the shelf, or do you build your own? Do you use SaaS from the clouds? There's lots of different options these days. You're building your own. Do you use what patterns do you use? Again, there's some quite fundamental options: microservices, SOA, event-driven architecture. You're going to have to integrate with different solutions. Very few solutions these days are standalone. So how do you integrate? How do you design interfaces? What integration patterns do you use? And there's lots of general things to consider here around your approach. Pick a few out. So multi-tenancy. So your users, do they all use one application which is split up in terms of different tenants? How do you partition access and data? And you will see these three very commonly in these slides and in the book: performance, reliability, and security. Really key tenets of non-functional support that I'll address a bit more later on. Again, as I've said many times, there's much more detail on each of these decisions and each of these and guidance on how to make these decisions in the book. But on data, so this is what I call the data decision wheel. I don't think that's the official term, but I quite like it. But this is from the DMBOK, the Data Management Body of Knowledge. And this outlines some of the key parts of data design that you need to contend with. I'm not going to go into any detail on these, but much more detail in the book. But maybe just to pick out a few. So you need to have an overall data architecture, and there's a good chance within the enterprise architecture that there will be standards that you and best practice that will help you with that. How do you secure data? How do you where do you store reference data? I won't go through each of these, but much more detail in the book, and also links to the DMBOK, which is a really good reference for data design. And also we cover data store types. So lots of choices these days from, and this is kind of generally ordered from your very short-lived data through to your very long-lived data. Lots of choices, and you need to think of things like performance, cost, how important is the data, how resilient does it have to be. There's lots of different choices there. User experience, so you're going to have to have users using the solution. It's unlikely there won't be users of the solution. It may be internal users, but they may be external, and it may range from a few users to thousands and thousands of users. It really depends on the solution. But likely you will have to address user experience. Very important that the solution is usable from an end user perspective. So things to address are how do you map the journeys, the flow of the user from logging in to using the application. Wireframe is a very good approach to prototyping UIs. You need to measure how good or otherwise the UI is. And these are some suggestions on doing that. And it needs to be accessible to all, with people with different sensitivities and so forth. Application performance. So how do we size the application to make sure it will meet the resource demands? How do we scale to increase demand and preferably auto scale, so we don't have to do this manually? How do we load balance? And this is also linked to resilience. So if we have to remove, for whatever reason, some capacity, how do we scale across? And how do we load balance across the healthy parts of the application? And how do we tune to make sure we get best use of existing resources? It's worth at this point saying, just going back to an earlier video, the people, process, and requirements, is we should have our performance and also resilience and security targets and requirements agreed at this point. Doesn't mean they can't change. We are an agile, we can be flexible, but we need to understand what we're aiming at. What we shouldn't be doing at this point when we get to doing, for example, application performance design, and the same applies to reliability or security, we shouldn't be asking, right, what are our requirements? We should know those. Those should have been discussed, and those should have been refined as part of requirements and backlog grooming. So they shouldn't be a surprise. As I say, it doesn't mean they're set in stone, they cannot change, but we shouldn't be doing requirements here, we should be doing implementation of requirements. So just a little bit going off a tangent there, but it's really important to state that point. A bit about application reliability here. So this is how we address the service being up and available for users or for whatever purpose it's being used for. So some areas to address here is it self-healing? So more and more there's use of AI or other less elaborate approaches to automating fixes of applications without requiring manual input. Application load balance, that came up in the previous slide, but it's also important for resilience as well to make sure the service is still available even when parts of it are not, or either planned or unplanned, being taken out of the application. And clustering is good, another implementation of that load balancing approach. How do we reliably integrate with other applications, other solutions? So we will be integrating almost undoubtedly with our solution. How to make sure that that integration, for whatever purpose it's for, is reliable, including if there's issues with the entity that we're integrating with. How do we back up our data and replicate our data? And related to that, if we had a full site failure of an application, how do we continue service? Can the application be deployed elsewhere and maintain service? So into security, I think the concept of the shared security model is really, really important, really useful, especially when you're using the cloud, but it doesn't have to be public cloud, it could be private cloud, but it's a really good way of visualizing security responsibilities. And this is just one take on it, and this is more for the traditional infrastructure as a service model. If you're using things like platform as a service or software as a service, the cloud provider will have more and more responsibilities. The key thing to address is from a solution perspective and solution architecture perspective, what are your responsibilities in terms of security and areas of security you need to address, and what are other people's responsibilities? All about scoping. It's not about removing your responsibilities, just by being very clear what your responsibilities are and what other people's responsibilities are. And in this model, so this is a kind of infrastructure as a service model, the cloud provider would be responsible for physical network and virtual infrastructure, and the user of the cloud would be responsible for these aspects. As I say, these models will change, the responsibilities will change depending on the model. It's important to establish up front what those responsibilities are. Because then we get into, well, there's a whole bunch of security you may or may not have to address. And the big list here, I won't go into this in detail, again, covered in the book in detail, but lots to consider in more and more these days when there's so many potential threats to solutions, both internally and externally. That's the modern world. And luckily, there's lots of controls to those threats, but you need to build those into your architecture and design. And these are some suggestions on areas that you should address. A lot of this comes down to security requirements and costs, but it's important to use best practice, and some of this is my suggestion, best practice as a checklist of things to address in your application security design. A little bit about OSS and BSS integration. So OSS is these are systems which help manage applications. There may be things like monitoring, capacity management, security management, that sort of thing. BSS is business support, so that's things like getting orders from customers, billing customers. So quite often your solutions will have to integrate with one or more of these systems, likely multiple of these systems. Again, it depends on the scale of the enterprise, but really important something to think up front about, because it's quite common people will think more about the technical aspects of their solution. How do I meet my feature requirements for this particular product? But this is a little bit the production support wrap. So, well, you need to meet your feature requirements, but you also need to make sure, well, if a customer is buying something, you can bill them, or your system we can monitor that your system is available. So this is all about integration into the wider support wrap. And most large enterprises will have established OSS and BSS frameworks that you can integrate with. So that's about application and data design. Now we're getting into the infrastructure design. How do we host these applications and the data that they're processing? So this, similar to the previous topic, I outline the common decisions you have to make when doing infrastructure design, and you'll see these common three again: performance, reliability, and security. The three key areas, not the only areas, but the three key areas of non-functional support, which come up time and time again. So key deployment infrastructure design decisions. I won't go through these in lots of detail, but it's around how do you manage the infrastructure that you're building, where you're going to host it. Is it going to be public cloud, private cloud, a mix, on-prem, might be even specialized hosting. These three, compute, network, and storage, kind of all often bring these together, because especially when you get to the more virtualized realms, they're often virtualized, so they come as a triple. And I've outlined some of the key decisions to be made there, and you see again at the bottom the three: performance, reliability, security, which flows throughout almost all decisions that you'll make, both for application, data, and infrastructure design. So I won't go into much detail. I mean, I could pick out an example of decisions. Containers for virtual machines is a really common thing at the moment. Containers more and more important, but there are still good uses and good use cases for virtual machines. It's just an example of decisions you have to make. What storage you're going to use. There's loads of different storage options now, and the choices will depend on your performance, your cost, your reliability needs, security needs, etc. So yeah, on the topic of infrastructure performance, so there's some key things to think about. How do you scale your infrastructure? If you're using physical servers, how do you ensure you purchase the servers that meet your performance needs, and same for virtual. Storage performance is really important, especially as we get into larger and larger data sets. Network load balancing, how do we load balance across the network? So kind of this would be layer 2, 3, 4 level of the OSI stack. And how do we ensure strong network performance which meets our solution needs? Okay, more detail covered in the book. Reliability of infrastructure. So if we're deploying into a data center, how do we ensure that's resilient? Same with physical and virtual servers. Self-healing infrastructure. So if servers go down, how can they heal themselves in some way? So we covered self-healing applications in the previous slides. Same goes for infrastructure these days, especially when we get to virtual infrastructure, where you would expect more and more. You lose a server, another server takes its place. That's more and more an expectation rather than an aspiration now. How do we cluster servers again, playing into the reliability, resilience aspects? Yeah, network load balancing. Again, it's covered in the previous slide, but also it's an important part of resilience. So if you lose a part of the network, how does the solution carry on? Is ensure we have no single points of failure, and ensure we can lose one part of the network, but the service is still available. And if we lose the entire site, what does that mean for the solution? Can we carry on? And the service is an alternate site which will host the applications and data. And then infrastructure security. So key decisions to be made around here. I won't go to this in any detail, but some important decisions to be made on security controls that you can deploy to protect your infrastructure from your expected threats or unexpected threats. So again, I cover this in much more detail in the book. So that's a bit of a whirlwind tour of application and data design and deployment and infrastructure design. So these are the topics that will drill down on your solution architecture and get to the design level. And I've covered, I think it was in the first slide, I covered architecture against design. And I don't like to see it as there's not a complete separation, it's more of a spectrum. But the more and more you get into design, what you're doing is creating a plan for implementation. So your solution architecture or series of end-to-end views, which your designs use, and your designs are your detailed plans, which your implementation will use. And this is what you build from via coding or configuring network storage devices and infrastructure. But these are your detailed plans that you implement from. So this is a very, very brief tour of what's covered, much more detail in the book in terms of those design plans. Now, next video, we're going to cover the other topics that make up the framework in terms of seeing through your solution in life. Again, I don't want this to be seen as a phased approach. This is not waterfall, so it's not a case of you do your solution architecture, you do your design, you do your testing, and in life, because in life it's done, and I covered this in the second video. It's done. It's a series of sprints, so you will be doing a lot of these all in one sprint as you break up your solution into different deliveries. So it's just important to emphasize that. Just to summarize, so the book is available on Amazon in 2 different formats, and these are my contact details. So I'm always delighted to hear from anyone if you want to discuss anything around solution architecture or anything in IT industry. Really delighted to hear from anyone, like to make new contacts and discuss anything with anyone and collaborate. It's really enjoyable collaborating with like-minded people. So those are my contact details. So I look forward to hearing from you, and thanks again for viewing this video, and I'll see you on the next video. Thanks again. Goodbye.